Hi everyone. Today we're going to be talking about our third method for solving systems of equations. So let's just do a quick review. So far, the two methods that we have used for solving a system are graphing and substitution. When we're solving a system, there are three possible solutions for a system with two equations. So we're just going to briefly sketch and label those three types of solutions. The first one is where we have two lines that intersect. So two equations that give you two lines that intersect at one point. This means that we have one solution. If we have two equations that graph lines that never intersect, that are parallel, then we say that there are no solutions. And if we have two different equations that graph the exact same line, so we end up with just one line on our graph, then we say we have an infinite number of solutions. Okay? So this is what they look like in graphs. We have talked a little bit in our previous notes about what they look like algebraically, and we'll touch more on that next class. All right, so now let's just do a little bit of practice here. Just a quick review. Okay? I want you just to complete these two problems on your own, just to review how to solve by graphing and how to solve by substitution. Okay. Go ahead and pause your video now. Okay, now let's get ready for elimination. So let's talk about additive inverses, or canceling out. Canceling out, well, let me go back. Elimination means to get rid of. So in math, we use kind of that phrase canceling out. That helps us to get rid of certain things. So when we want to cancel something out, we have to use the additive inverse. So what we're going to do here is write the term that will cancel out to zero the term that's given. So what is the additive inverse to a positive 5? Well, its additive inverse would be negative 5. The additive inverse of negative 8 would be positive 8. The additive inverse of 2x would be negative 2x. And the additive inverse of negative 5x would be positive 5x. Okay, I want you to do these next four on your own. Go ahead and pause the video now. Okay, let's go to the next page. All right, now, what if you wanted to cancel out two terms, but they weren't inverses of each other? What could we do so that they would cancel out? So I've got a 3x. I want to make this bottom one a negative 3x. I need to make them inverses. So how can I make this a negative 3x? Right? Well, I can multiply it by a negative 1. So negative 1 times 3x will give me negative 3x. Now these two terms are additive inverses. I can do the same thing here. I've got a negative 2x and a negative 2x. So to make this the additive inverse, I need to change it to a positive 2x. Again, I can do that by multiplying by negative 1. All right, well, this time I've got a 5y and a 1y. I need to turn this 1y into the additive inverse of this. So the additive inverse of 5y would be negative 5y. So how can I turn a y into negative 5y? Well, I can multiply it by negative 5. Right? And then this one, I'm starting with a negative 4y. I need to get to its additive inverse, which is a positive 4y. So I'm going to multiply this y by a positive 4. All right, now I want you to go ahead and try this next set on your own. Go ahead and pause the video now. All right, good. Now let's talk about the elimination method. This method works great when both equations are in standard form. It means my x and y are together on one side, my constant is on the other side. So let's take a look at this first example. Let's notice that both equations are in standard form. While we could graph or use substitution, elimination method is probably going to be the quickest at this point. So our first step is to see if any of the variable terms are additive inverses. So I see I have a positive x and a positive x. They are the same. They're not additive inverses. Let's check out the y's. I've got a positive y and a negative y. Right? Those right there are my additive inverses. Okay? So since the y's are inverses, right, we can add these two equations together. And here's what's going to happen. My inverses cancel each other out. Remember, that's kind of the purpose of having inverses, is we want those two to cancel out. We are eliminating my y's. Now that I've eliminated my y's, now I can add my two equations together. So I can do x plus x gives me 2x. And then I can come over here, negative 3 plus 1 will give me negative 2. So x plus x is 2x. Bring down my equal sign. Negative 3 plus 1 is negative 2. All right, now we can just solve this equation right here, okay, for x. Divide both sides by 2. And we end up with x is equal to negative 1. All right, now that we've solved for x, we've found the value of x. Now we can use this in one of our original equations. We can go back to either of these two equations, does not matter which one, and substitute this in for x and solve for y. I'm going to go back and use the first one because both of my variables are positive, and I like dealing with positives. That's my only reason for picking the first one over the second one. So I'm going to use that original first equation, x plus y equals negative 3. I'm going to substitute negative 1 in for the x, and now I can solve my equation for y. So I'm going to add 1 to both sides. 1's cancel out. I'm left with y is equal to negative 2. So now I can write my solution. Remember, my solution has to be an ordered pair. So negative 1 and negative 2. Right. So now I want you to come down here, and I want you to try this one here on your own. If you notice, your y terms are your additive inverses, so they're going to cancel out. Go ahead and pause the video now. All right, let's go to the next page. All right, now, what do we do when variables won't cancel right away? Well, when that happens, we can use multiplication to make it happen. Our steps are going to be the same as the ones in the previous page, but because nothing's going to cancel at first, we have to think about what we want to eliminate. All right, and this is where we're going to have to come up with those additive inverses by multiplying. All right, so I have to determine, do I want to try and eliminate my x's, or do I want to try and eliminate my y's? So in order to make this a little easier on myself, I first like to take my smaller variable term and compare it to the bigger variable term. So in this case, the 6 to the 9. And I'm going to ask myself, can I easily multiply 6 by something to make it equal to 9? I can't. So eliminating the x's may not be my best bet right now. Now, on the other hand, if I take my 2y and compare that to the 4y, can I multiply 2y by anything to make it equal to 4y? I can. I can do 2 times 2. Right, now I need to check my signs. Right, so my signs are already opposites. So I already have the inverse happening here. Now I just need to get my numbers to work together for me. So I need to get that 2 to equal a 4. So in order to do that, okay, I can easily turn my 2y into a 4y by multiplying by 2. So I'm going to take that original first equation. It's the only one I'm going to change because I want to change this 2y into a 4y so that these two terms become additive inverses. So in order to do that, I need to multiply the entire first equation by 2. I can't just change the middle term. I have to change everything to keep it balanced. All right, so I'm going to distribute that 2. So 2 to the 9x, 2 to the 2y, and 2 to the negative 30. Once I've done that, I end up with 18x plus 4y equals negative 60. I'm not going to make any changes to the second equation. I don't need to. So I just bring that one over here. I slide it over. It's exactly the same. Now we can see that my y's are additive inverses. Right? A positive 4 and a negative 4 will cancel each other out. Now I can add my two equations together. 18x minus 6x will give me 12x, and negative 60 plus 12 will give me negative 48. Remember, we're adding these two equations together. All right, so now I can divide both sides by 12. And when I do that, I get x equals negative 4. All right, now I found x. Now I need to find y. So now we can substitute the negative 4 into one of the original equations and solve for y. So going back up to my original equations, again, it does not matter which one you use. You go by your own personal preference. My personal preference on this one would be the first equation, because both of my variable terms are positive, and I like dealing with positive numbers more than I do negative numbers. So I'm going to use the first equation. So I'm going to start with my 9x plus 2y equals negative 30. My x value we know is negative 4, so I'm going to substitute that in and simplify. Okay. Now I can start solving for y. Right, so I'm going to add the 36 over to both sides. Those cancel out because they're additive inverses. We're left with 2y equals 6. So now to solve for y, I can divide this by 2 and divide this by 2. Once I've done that, we get an answer of y equals 3. My final solution again is going to be written as an ordered pair. Negative 4, comma 3. All right, let's try a couple more together, and then you're going to have 2 to complete on your own. All right, so when we look at this one here, I'm going to check out my variables to see which one might be easier to eliminate than the other. So I notice with the x's, they're both negatives. I notice with the y's, they're both positives. So I don't have any opposite operations or signs happening. Now I'm going to pay attention to just the variable terms themselves. Can I turn a 9 into an 18? I can. I can multiply 9 by 2. Can I turn a 2 into a 3? Not very easily. So it looks like the x's are going to be my best bet to eliminate. So now I need to start thinking about these signs. I need them to be opposites. Since I'm changing the 9x, I want to get that into an 18, I'm going to change this negative to a positive. So to turn my negative into a positive, I need to multiply by a negative number. So I'm going to have to multiply this entire equation by negative 2. Because negative 2 times negative 9 will give me a positive 18, which is the additive inverse to negative 18. All right, so I'm going to distribute my 2 to each part of the equation. Once I've done that, I have a positive 18x minus 6y is equal to negative 54. Make sure you watch your signs. I'm multiplying by a negative, which is why this changed to subtraction and why this changed into a negative number. I am not making any changes at all to my second equation. I'm going to leave that exactly as it is. Now we notice that these two are additive inverses, and they will cancel each other out. So now we can just add our equations together. Make sure you realize or pay attention to that minus sign in front of the 6y. That's really a negative 6y at this point because we've canceled out these 18x's. So negative 6y plus 2y is a negative 4y. Negative 54 plus 30 gives me negative 24. Now I can solve for y by dividing both sides by negative 4. And that gives me y equals 6. Now that I know what my y value is, I can take that, substitute it back into one of these two equations to get my answer. In this case, doesn't really matter which one I use at all. So I'm just going to pick one. I'm going to pick the first one just because I don't know why. I had no real valid reason for picking the first one. I just decided to go with the first one. So now this time I know what the y value is. I'm going to substitute 6 in for y. I can simplify the 3 times 6, gives me the 18. Now, to isolate the x term, I can subtract 18 from both sides. Those 18s cancel out. And we're left with negative 9x equals 9. Divide both sides by negative 9. And we get, if I can find it, maybe I didn't type it. We'll type that in now. X will equal negative 1. Now, when we go to write our final solution for this, we have to pay attention to the order. Right? My x was negative 1, my y was 6. So when we go to write our final solution, we have to make sure we put the x value first. So my solution will be negative 1, comma 6. And I'm just going to put a box around the answer just to kind of separate it out from everything else. Okay. So let's do one more together. Let's come down here and take a look at this problem here. All right, now this one is going to require a little bit more work. So I'm going to take a look at my two equations, and I notice that my x terms have opposite signs. That's good. I like opposite signs. I need opposite signs. Same thing with my y terms. They're also opposite signs. Now, when I look at my x's to see, can I turn my 3 into a 4? Not very easily. All right, so I'm going to check my y's. Can I turn a 6 into a 9? Again, not very easy. So here's what I'm going to do. I'm going to just pick a term that I want to eliminate. Do I want to eliminate the x's or do I want to eliminate the y's? I think for this one I'm just going to eliminate my x's. That's the one I'm going to choose to eliminate in this case. So in order to eliminate them, my best bet, since I can't easily turn a 3 into a 4 or a 4 into a 3, is I'm going to multiply my top equation by 3 and my bottom equation by 4. So basically I'm going to switch those two numbers. Since my signs are already opposite, I don't need to do anything with signs. Okay? I want the top one to stay negative and the bottom one to stay positive. So I don't do anything with signs. All right, when I distribute the 3, I end up with negative 12x plus 27y is equal to negative 18. And when I distribute the 4, I end up with 12x minus 24y equals 12. Right. Well, now I have my additive inverses. I can eliminate my 12s, and I can add the rest together. So I've got 27 minus 24y, oops, gives me 3y is equal to negative 6. Now to finish solving, I can divide both sides by 3, which gives me y equals negative 2. Now that I know what y equals, I can take that and I can substitute it back up into here. All right, so I need to solve for x. This is going to help me pick which equation I prefer. Again, it doesn't really matter which one you pick. Knowing that I have to solve for x, I'm going to pick the second equation this time because my x term is positive. And I know I'm going to make less mistakes if I use the positive version versus the negative version. Again, though, it does not matter which equation you use. So I'm choosing the second equation. I'm going to take that negative 2, substitute it in for y. simplify this, so I end up with 3x plus 12 equals 3. Remember, that's technically a -6 times -2 gives us the positive 12. Now I can subtract 12 from both sides. 12s are additive inverses and will cancel out. Oops. Keep doing that. Okay. We now have 3x is equal to -9. And now I can divide both sides by 3. And we get x is equal to -3. So I did my y's first, then I found my x. So once again, when you write your solution, pay attention to the order. The x value has to go first. So my solution is -3, -2. All right, I want you to save, or I want you to do these last two problems here on your own. There is a set of problems on the next page. We're going to save these last few problems for your homework for next class. Right? So this one will be your homework for next class. Right? So your job now is to go ahead and complete these two try on your own, and I will see you next class.